Good morning, everyone. Hope that you had a nice day yesterday. And today we are going to do a different kind of session. It's more technical. And we will start with Gianmarco Gabrielli, who is a researcher at IBM Zurich. And he will be doing a recap on the crypto anchors lectures that we have been had in the past. Afterwards, we will have different colleagues from INL presenting a data flow demonstration that they have done with these candy colors that you can see here. And at 11, we will have a break, and we will continue afterwards with the demonstration, and you can do some testing. Okay, so welcome, Gianmarco.
Thank you. Okay, so thank you very much, Nuria, for the introduction. So I'm really glad we are here in Braga again. So finally, we can have these meetings in person. So today, as Nuria said, I will basically recap what we have seen in a previous technical workshop, in which we have introduced the concept of crypto anchors, and then we have shown a few examples of authentication pipelines and processes. Don't worry if you didn't take part to the previous session, because we'll try to basically introduce again the concept and recap for all of you. So yeah, I hope I will be short so that we can go directly to the fun part with what the other colleagues from INL prepared. But yeah, so in this presentation, basically I will mention again what crypto anchors are, and basically how we can enable authentication of physical objects with an example on sensing technologies, and especially one sensor that we develop at IBM. And then we will see what we can do with the authentication results. So how can we go really into the application, of course, related to blockchain technology. So when we talk about crypto anchors, we basically refer to physical objects or physical properties that can uniquely identify an object. So you have to think of all the possible attributes that we can give to a physical object in order to make possible the identification of the object itself. And of course, the crypto anchor it's really important, is necessary, because if we are able to uniquely identify that physical object, then we can authenticate the object, and therefore in all the possible verification flows that we will have in the different applications, we can use the crypto anchor in order to securely identify the object. So of course, depending on the type of material and object that we want to identify, we can have a different implementation of the crypto anchor. So we can think of properties that we can induce in the material during the fabrication, for example, of the object, or something that is intrinsic to the material during the fabrication. And these are the so-called embedded security features. So you can think of the microprinting that we have, for example, on the money, but also like the security inks or the holograms or random patterns that we can generate during the production. But of course, we know that there are some of the other crypto anchors that we configure, like the crypto keys or passwords. So these, of course, are used in order to identify finally the ID or the serial number that we associate to the object. But of course, we can have also physical fingerprints. So this is most common in our domain, in which we can basically create a fingerprint of the object on the object itself during the fabrication. And you can think of the electronics chip, in which we can basically, without modifying the functionality of the chip, we can induce on the hardware a slight change in order to make that chip possible to be identified. So these are all examples that we can have of crypto anchors. And basically, so most of the time, it's not always the case, but most of the times we have the object manufacturer that is the one inducing or producing the crypto anchors along with the object itself. But the object manufacturer can also commission the crypto anchors to crypto anchors vendors. So there are companies that, for example, are only related to basically designing and creation of these crypto anchors. So the object manufacturer can commission the fabrication, and of course we can then attach that crypto anchor to the object in a second phase. And so all this information and when we link the object to the crypto anchor is stored usually in an authentication service. So we have, or the object manufacturer has to give this link to an authentication service. And of course, to access this information, we will need a key in order to make sure that we have access to the correspondence between the ID and the crypto anchor itself. So in this game between the object manufacturer and the authentication service, we actually have other players because, of course, we have other application or backend applications that may require to access the information. And this is the case of the, for example, supply chain management that will access immediately the authentication service through the key that is appropriate for that object in order to retrieve the information that is needed. And one important part in which I'm going to focus in the next slides is authentication app that we can have in the field. So when we have sensing technologies that we will need in order to actually identify that fingerprint or discover the fingerprint, we can verify whether the fingerprint that we found out is correct. Again, accessing the authentication service with the key in order to make sure that the analysis that we have done is appropriate. And then, of course, the sensing technologies can forward the information to other apps or, of course, can communicate back to the object manufacturer in case there is detected like counterfeiting or any other issues in the authentication that we have seen. So, as researchers and scientists working on different applications, of course, some of you may work on the actual fabrication of the fingerprint, so inducing on the material that we have the crypto anchor itself, and some others will or are working instead of sensing technologies in order to basically identify that fingerprint. And so this is our job as a researcher in order to enable what we call the authentication backend, basically the authentication service that I mentioned in the previous slide, in order to enable that process of exchange of information on the physical object and on the crypto anchors. We will need to basically go through the digitization flow in which we go really from the sensor to actual data that can be used by the authentication backend. And we will have different components that I will describe in the next slides that will help us in order to provide the actual information to the authentication backend, and this can then be used for the multiple application. So yeah, in the previous technical workshop, we have seen already this stream of, let's say, the data, the way we build the data that can be given to the authentication backend. So when we have sensing technologies in order to identify the fingerprint or verify the object properties, we basically need to have, of course, hardware components in order to generate a signal or something that we can get when we measure the actual physical object. And of course, this information has to be digital, because this is the way it will be, in the end, interpreted by the authentication backend. So whatever measurement we produce, this will be digitalized. And a really important step will be then the communication service in order to transfer the digital information to the database when we store all the information that we gather with our sensor. And of course, the analytics. So the part in which we identify that fingerprint, we say, okay, that fingerprint corresponds to what we actually were looking for or not. So it's like the authentication process itself. And this will be provided again also to the authentication backend, so to the service that help us to communicate then to object manufacturers or like other apps. So there are many examples in which this can be implemented, depending really on the technology that you are working on. So what I wanted to mention was basically 2 examples of communication service that we have. Of course, these are not the only ones that you can use, but basically are the ones that are the most used. And of course, there exists also hybrid implementation of the two. But basically, when we want to stream out the data, so the digital information that we encode, we can do this directly with the server through the so-called point-to-point architecture, in which we measure with our sensor and then send our data to the server with a request. So this is what we have measured. And when we can retrieve back a response from the server that can authentify or not. And the other approach will be to use broker-based architecture. So the exchange between the sensor measurement and the server is not direct, but we have an intermediary unit, the so-called broker, that stores all the information published by the sensor in a queue. And when the server can retrieve the information, it will be subscribing to the queue in order to get that information. So what is the difference between the two? Why there is this broker-based architecture? So usually in the first approach, the exchange has to be synchronous. So as soon as we send a request, we do expect a response. And this, of course, is optimal in the case in which we have connectivity and we don't have any issues in interacting with the server, so we can get back immediately the response. And usually, the way this is done, it's quite, let's say, flexible, because you can request to the server many type of information. You can retrieve the response in different formats. In the case of the broker-based architecture, instead, the advantage is that we have not a synchronous response, so it's asynchronous, because we can, whenever it's possible for the sensor, so imagine, I don't know, like remote sensing application in which the connectivity is not possible directly to the server, we can just publish our measurement to the broker. And then when the connectivity is possible, we can, with the server, retrieve the information from the topic exchange. And this is efficient and being used in many of the IoT applications, because the type of message that we have in the broker is predefined. So imagine that we have a sensor that always measures the same thing. So of course, the type of message that it sends to the server will be always the same. And the broker has this structure in which it always expects the same type of format, and therefore is really fast. So even if we have like connectivity which is not optimal, of course, since the broker is already set to receive that type of information, this can be done easily and in a lightweight format. So this is the advantage of using this type of communication. So both of them, as I said, work and are really mostly used in sensing technologies. But the second one is the preferred for IoT applications, for the actually applications that are in the field, with respect to the first type, which is more like, let's say, more complex, and that can be used when we actually have a lot of connectivity with the server. So at IBM, we have done this exercise of going through these steps with one of our sensing technologies. So for those that don't know, this is Hypertaste, a sensor that we used to fingerprint liquids. So we used interaction of conductive polymers with liquids in order to extract information related to the concentration of the compounds in that liquid, or to fingerprint that liquid and differentiate from the other. So also in this case, we had to go through implementation of few hardware components by having this connector in order to gather the signal that we get from the conductive polymers. Probably you don't see from there, but here it's we have materials here that interact with the liquid part, and then we extract the information, which is an analog information. Then we have an analog to digital converter, because as I said, we need the information to be digital. Then we have that information being passed through the communication service, and this can go either to the database that can store all the measurements that we performed, and each of these measurements can then be used in order to, with the analytics, in order to identify the liquid that we measured. So here is an example of sucralose, which is an artificial sweetener, for example, that we can identify with this technology. So, and just as I said, it doesn't exist a unique way in which we can implement the communication service. So here I explain two different approaches that we had. So we call our sensor citrus because of the citrus shape. Imagine when you have a lemon dipping into a glass. And we have two different generations. There was a previous one which was just able to stream out data, but here I explained two implementations to recall the different communication service that we can have. So in Citrus 2, we had the data that were sent to a smartphone. So we have a Bluetooth module. Yeah, actually I have the pointer. So yeah, a Bluetooth module here that was basically able to send out the data to the smartphone. And then, as I said, since we had a smartphone and the server, we could use then the hardware approach with the point-to-point architecture. So we directly transfer wherever we had the phone, we had also the connectivity, we could transfer the data to the server and then get back the result on the smartphone. Instead, in the second or third generation of the Citrus port, we had the broker-based architecture. So our sensor board was able, through a specific Arduino board, to send the data directly to the intermediary unit, this broker, in a specific message queue. And then there was the server interacting or subscribing to the queue in order to get back the result of the analysis. So just to recap, in the first case, so with Citrus 2, we directly measure in the liquid. We collect differential voltages that are sent out with a Bluetooth module. So you see here the interaction in time of the sensor with the liquid. And then after the collection, the smartphone interacts with the server through REST APIs in order to analyze the measurement that we perform, and then we get back the result on the smartphone. So here, for example, is the concentration of 4 different ions in that liquid. While in the second approach, we had the direct streaming of the data. So these differential voltages that we measured through RabbitMQ, which is one of these brokers that I mentioned. So these data were streamed or published to the queue. And then there was a database, which is called InfluxDB, that was subscribing to the broker in order to retrieve the information that we get from the sensor. So then we have the analytics that can be implemented anywhere, because as long as we have the data on our database, means that whatever possible application we can use to access the database, then we can perform the analysis of the liquid. So this is the different approach that we were using with the Citrus 3, and this was just an example to show you how this communication service will work. So the database is an important part of this whole process, because, of course, with the database, we need to store all the information that we, or all the data of the measurements that we have performed, because it might be that we don't have the possibility to perform directly the analytics on that, so we need to store that. And usually, this is just again an example, InfluxDB is one of these database. We had to configure this subscriber file because the InfluxDB was subscribing to the queue provided by the message broker, and we have to uniquely identify a place in which all the measurements will be stored. So in this that database, we have usually the tokens, which are like the unique identifier of all the measurements that we perform. And when we configure this subscriber file, in addition to mention what is the token of the messages, of course, we need to specify again what is the broker queue to which we subscribe. And then there is just a couple of commands that we can perform in order then to make sure that the database will get those measurements. And then after we have the database, the measurements in the database, we can perform analytics. So we have two different types of measurements that we can perform. For example, on the liquids with hypertaste, so you have the identification of the liquid. So the distinction of a liquid in different classes. So is this liquid A or B? And this is done through classification models. So we apply this model to the data that we have in the database. Otherwise, we can also perform regression. So we measure a certain quantity associated to the liquid. So we might have also the regression of multiple elements in order to uniquely identify that liquid. So all of these can be used, as I said, to fingerprint that liquid uniquely. And so I'm almost at the end. So usually, how do we then transfer basically the result of all these analyses to our authentication backend? So usually what we do is to generate this JSON file. Is basically a format that we use when we send out the data to the authentication backend. And we can have, as I said, both classification or regression. And exactly this classification step is what we call the authentication result. So this is, as I said, the fingerprinting of the liquid. So to make sure that that liquid is exactly what we expected or not. So here we identify the class. Then if we suspect that the liquid was another class, of course we have an issue with the authentication. If there was the same class as the one that we predicted, then we are sure and we can inform all the other players in the authentication backend exchange that the authentication result was successful. So this is the final format in which with hypertaste have these results. So here, I don't know if we'll start the video or not. Yes, so this was just an example on a project we have done with a distillery in Berlin to identify possible modification of gene. And we basically here move the sensor from a reference liquid to the test liquid. So you see here the data that we record when we move from reference to test. And then we get a result immediately because we have the model on the phone. It will say that is a modified gene with all the possible statistics. So when we get to this moment of having the result of the analysis, we basically generate what I mentioned is the JSON file. So is this JSON file enough to communicate with the authentication backend and so on and so forth? No, because we need to make sure that the JSON file is signed. So the JSON file has to be encrypted and be accessible only through specific keys. So usually there are two different ways of doing this, but again, not the only ones, which is through this JWT service or Passeto service. This basically makes sure that the JSON file that you create can be encrypted and associated to a key, then can be then understood by the authentication backend and by all the players that basically interact with the authentication backend. So usually we have common fields that need to be specified when we use JWT or Paceto. So we have, of course, an ID related to the issuer and to the subject, so to what we measure, and the time at which the analysis was performed. So depending on the JWT or Paceto standard, we have different ways in which this needs to be specified. But all of this is necessary and required in order to then go to the final authentication result. And when we sign a JSON file is the moment in which we generate an authentication token. So we go from the authentication result to an authentication token. So now this can be used by all the other services in order to be accessed through specific keys. So just to wrap up, of course, as I said, after we generate this information, we have multiple applications in which this can be used. So of course, whenever there is a mismatch between the authenticated class and the claimed class, we have an issue, we can issue a warning. So there is probably a problem with the authentication process. So there is something that didn't work, the verification didn't work. But of course, we have many other applications. So of course, we need, and we have seen yesterday a few examples in which we interact between producer and consumer to make sure that the provenance of the product is correct. And of course, we can give access to, this is an example because there are some apps that give access to premium content. After we get the authentication result, that can be accessed through the app in order to go beyond the provenance. So the multiple information on that object. In the case of liquid, can be the concentration, for example, of the chemicals. And ultimately, one of the main applications is, of course, in supply chain management. So imagine that we can have multiple authentication steps within the supply chain. We can discover whether or not there has been a counterfeiting issue. So if we have a warning in that case. So yeah, this was the last slide. I hope it was clear. So if you have any questions, don't hesitate to ask. Thank you.
I'm very... Thank you very much, Gianmarco. It was really interesting. I have a question, but I don't know if it's my lack of knowledge or... between Paceto and the other system, the JWT, is there any specific factor that made us choose one or the other one? Because I saw that Paceto was agnostic, depending. I mean, it doesn't depend on the platform. You can use it for different platforms. I don't know if the other one as well, or yeah.
No, yeah. So you answer your question because so Paceto is this platform agnostic library. So this means it's indeed new compared to the JWT that is the most established. So usually Paceto gives the possibility to make this authentication token available to additional services with respect to JWT, even though JWT is the most established because it was already well developed, yes. So it's a trade-off. So depending on what you need to do and to whom you need to give the result, that you will need to choose one or the other. So, yeah.
Any other questions?
Yeah.
Almost the last slide, you showed the JSON file.
Yeah.
And you have the latitude and the longitude.
Yeah.
In the, why is this information used? I mean.
So so for actually this is just an example. The actual field that you need to have are the one in blue. So the latitude and the longitude, it's just an additional info that you can give if you have a geolocation on your phone, but this is not required, okay? So if you don't provide the latitude and longitude, you can still have a signed JSON. So this is just an example from my file, but you don't necessarily need it. So you really need all the other steps. So the issuer, the subject ID, and the time, this is mandatory. The rest is adds-on that you can give to the JSON.
I see that the authentication is very important, very much dependent on the machine learning model behind it. So to what extent can the quality of the model influence the authenticity result?
So of course, the model is the really important part in all this process, because if we cannot trust the model, then of course we cannot trust the authentication result. So of course what I show here is just an example on the pipeline as it should be, assuming that the model has been verified properly. Of course, the models, when we create models in machine learning, we always need to validate the models. And we usually need to apply the model that we train, in the lab with respect to the data that we gather in the field. If there is a mismatch, of course, we cannot go through this whole pipeline in building then sign JSON files, because we don't have the certainty. So there are, so depending on the applications, there are some threshold that you might have on the error that you expect. And of course, what we do, especially in remote sensing application, is to have some redundancy in the sensor, or you repeat the measurement, and after having gathered a result, then you can sign the actual JSON. So this is another option that we have seen in a few cases in which you have multiple sensors, assuming that they are small and portable in the line, and then you, when most of them, or like certain statistics of them issue a warning, then you can actually then create a JSON file and send to an authentication backend. So it really depends on the application and the type of model, because with the classification is easier, because usually we deal with binary classification, so is that liquid in or out of specs? And this is an easy task with machine learning, so we have many tools nowadays that are known. But when you need instead to, let's say, regress, so you need to quantify multiple parameters associated to the object, of course you might have an issue, because the models are much more complicated. So I foresee that this is more difficult to be done with all this process.
Eva, just related with that, so
Yeah.
do you consider when you just preparing these authentication files also include some kind of metadata information about the models that you use?
Yeah, so we usually have also info on the metadata. So we usually have the calibration measurements stored in the file. So whatever has been the calibration in that day, or the last calibration produced in order to get the result, it's stored in the JSON file that we have. Yeah, we have other metadata related to the model production, the model accuracy during the training phase. Yeah, these are the main metadata we put in the JSON, yeah.
Okay, thank you.
Any other questions? Yep.
Just to add to the previous question by my colleague about the latitude and the longitude is, is something that is very useful when you want to identify where the sample was measured. So if you want to bring the sensor to the different points of the food value chains, you can trace back, okay, this one was in that area, this one was in another area. So that could be really, actually very useful to pinpoint where the adulteration or contamination was taking place, yes.
Yeah, so indeed, it's, it's just not required because the JSON doesn't need, but it's really common because, as you said, it's super useful. So this is the reason why you also had in the slide.
More questions?
Sorry. Yeah, you mentioned there were basically 2 prototypes, or maybe more. You mentioned the second one and the third one. So if I can consider those as minimal viable products, or even the versions before that, were you involved in any of the testing with end users? Do you know anything about that?
Yes, I do know about that. So we, usually, for this specific sensor, we have partners that test the technology. And as you showed yesterday, is an iterative process in which we understand what are the limits and the weakness of the MVP, and we iterate to improve it. So the problem is that it's somehow dependent on the partner, because each partner has his own way of understanding its use case. And therefore, it's not an easy task to have a product that can be leveraged for multiple applications. So we try to do that. So almost to create this sensor agnostic platform, but it's really challenging. But this is what we need to do in order to make a success out of it. So I guess it's part of the process to iterate.
So the platform is sensor agnostic. Have you ever had a problem with really the quality of the sensor? So I can imagine some sensors are not well calibrated, or they sense signals with a lot of noise.
Yes, so we also have the issue that sometimes the sensors are really different. So even though the platform is sensor agnostic, we have a little bit of limitation because anyway we accept the same type of data, more or less, even though the sensor can be completely different. We still have to measure differential voltages in the case of hypertaste, and these voltages can come from my polymers or by, I don't know, someone else material or sensor array. We do have a calibration in place for each sensor in order to make sure it's standardized to the same format that we expect in the end to be used. We haven't tried many different type of sensor arrays. We have used 2 or 3 different types, and for each of them we need to tweak a bit the readout in order to make it then compatible to the rest of the pipeline. Yeah.
Any more questions? Nope. Okay. So thank you very much, Gianmarco. Okay, so now we move to the practical side of the workshop with different team members from INL. I don't know who of you will be starting, or all of you?
So I think I'm just actually taking a look on the schedule. So I think we have some time, but okay. So we have until 11. Okay. So probably the idea now is we'll just give a brief introduction and probably just a first demonstration. Okay. Then I was actually, after the Gianmarco's presentation, asked João to make a brief overview actually of the data flow of iGrape, because it's quite well implemented already, and we can also then take a look on it. And we could do probably that after the coffee break. And then we'll have time to discussion and probably also for the ones to interact with the system that we will present Okay, and I think that, I don't know if you agree on that, but just very, okay. So we can start with a short, presentation, and then João will play a little bit with the system. Can you put your presentation on? Just so actually, I think it's follow-ups quite well on the Gianmarco's presentation. Of course, with the differences, and try also to have some touches with a blockchain technology that we discussed yesterday. So we will just explore a little bit this workflow. So the idea, and give me just 1 minute to go back a little bit for contextualize everyone in the room. So we had a previous workshop where different groups from FNL presented multiple special sensor developments where they just produce data. Okay. We produced, relevant data that could be part of a digital pipeline. And the idea now is try to follow up a little bit on that. Let's say, we chose like a more agnostic example that could be easy to, if someone wants to reproduce, it could be reproducible. And it's quite easy also to understand, and it's based on commercial hardware, so anyone can then go back home and start to do the same thing that we'll present here. And we'll try also to introduce a little bit glimpse on the blockchain technology, how to produce the hashes based on the information generated. So we'll do the candy colors. We'll see that we have some candies here with different colors, and then we'll use a sensor to measure the color of the candy. So we'll use mostly what Gianmarco presented. So with some slightly differences, we don't have cloud databases. Everything will be local, but we'll have data transmitted with our Wi-Fi to a broker and then to a database. But let's go on the details, and then we'll just give a small touch on the blockchain. So this is the sensor that we'll use. You'll see on the left side, this is a spectral sensor. You see here a light source. This is an LED, and this is the sensor that can detect different colors. And then we have a microcontroller with a Wi-Fi connectivity where we just connect the sensor to the cloud. So this is what we are measuring here. So the sensor is like an array, a spectral sensor, where we can measure different spectral bands, okay? I hope that you are more or less familiarized with the spectral data, but this is indivisible, and we basically have all these photodetectors. They have bandpass filters on top, and you can basically detect intensities, okay? So we'll have 8 bands. We'll just work with this part here, okay? So basically our result will be like a number, so the intensities of these 8 bands, these 8 color bands. Okay, this is what you'll see in the second part that Gianmarco showed. Is the message go to the broker. This is where you see then here we have the blue, the yellow, the orange, or the different intensities of the different filters that we record. And now this will be stored on a database, okay? This will be local. We are not having this, and you'll see the exact same data in a table. And we also then add a column named color, which corresponds to the highest intensity found, okay? This should be our authentication, okay? And you'll see that you'll fail sometimes because the signals are very close to each other. Yeah, and then you will apply an algorithm to just also relate and create an hash based on the information, and then we'll see how this can fit in this box. Of course, we are not making all the consensus mechanism and so on, but this is just an idea for you to know how the pipeline works. Okay, so now I will give the floor to João. And first, I would like also to thank a lot to João and Álvaro because they did a lot of work to make this all the parts working. And so probably I think before, so João will present, and then we'll see the manage more or less the time. If you have time, you can also come to play and also here, or then we break and we'll see we manage the time. Nuri, you are in charge of that. João, the floor is yours.
Hugo, don't leave because I will need your help to run the experiments. But yeah, first of all, good morning, everyone. And also thank you, Hugo, for already giving some introduction. I will try to, yeah, the sensor is going to be on that. Yeah. I think the beauty of running something in real time is that it can go really well or really bad. So let's hope for the best. And I think right now, yeah. So basically, we will run at our first experiment 4 candies. The first one, it will be orange, then green, blue, and yellow. And I think finally the idea it will be to fulfill this slide as okay, is not showing, but yeah, basically we have a slide that we have the 4 blocks corresponding to each candy, and in the first block we will have the block hash and then the transaction, and in the second block we'll already have the previous block hash, making sure that the blockchain is working. Of course, this will be a simple example, but let's see. So Hugo already connected the sensor, and we can see here that we already can see the files inside the sensor. So right now we are going to the editor, and as I was saying, we will run this live. So I'm basically opening the softwares that we need to run every experiment. It might take a while. And basically we are opening the editor that allows us to access the code inside the sensor where we can run the experiments. In the meantime, we have here the Python code where here we have the main file, and basically we are accessing the database, extracting the data, and finally putting it on a blockchain. But firstly, I think we are already able to initialize here the database, where we basically are saying, okay, we are starting from the scratch. If some table with the same name already exists, we are replacing it to making sure that every experiment that will run will be stored. And right now, we are going to already run the broker file where we can access and guarantee that we are already connected to the broker, which Gianmarco already explained and with really good explanations. So right now, we already have access to the editor inside the sensor. So we are going to firstly connect to the sensor to the Wi-Fi, and we are already connected. So basically right now we are able to run the experiments. So yeah, Hugo, when you are...
So the experiment is quite simple, so we'll just switch on the LED and measure the intensities, okay? Just there. And you put an ID for the sample, okay? So we identify the sample.
You can run the 4 experiments,
okay.
And then we access them.
And now the last one.
Okay, so now we already run the 4 experiments, and now we can see the broker, where we already hopefully have the messages, and yeah, we have them. So for experiments, and hopefully we will detect orange, green, blue, and yellow, and yeah, a priori yellow will fail because the intensities are really similar between the bands. But let's see what we have. So right now we can run the full code, and then we analyze the different printings that we put in the code. Hopefully right now everything will run smoothly. Yeah, so we already have the entire thing. So firstly, yeah, we can look to this first part where we are displaying the database as a data frame, and when we are working with Python, working with data frames is, I will not say really easy, but at least is really convenient for those ones that are working. And basically we have here the IDs, and then the 8 bands as Hugo already explained. Then finally, and this is not like a proper analytics, but at the end we are doing something before putting it in the blockchain, that we are at the end of the day identifying the band with higher intensity and add a new column to our data frame. So finally, we are, not finally, but as the next step, we are displaying our experiments. And here we have 4 experiments. And basically, we are saying that, okay, what we want to put in the blockchain is, as the first transaction, candy with ID number 1 resulted in color orange. And then we have green, then we have a type of blue, and ultimately, yeah, we have orange. So not orange, but yeah, you understand the point. And right now, already in the blockchain, we have here our first block. Basically, the first block, as I already mentioned, only the transaction and the hash of the own block. While the second block, so here we can say candy with ID 2 resulted in color green, and we have the hash of the previous block. So here, and I know that are a lot of numbers, but there, if we see the hash of each block, we can guarantee that they are the same. And yeah, actually right now I can, for example, go to a Word document and put like a Control F to guarantee that we have the same. So yeah, don't you mind?
Yeah. If you have any questions, don't be shy. We have time to. So the idea is just to show you in a very simple way, how the workflow can work. Yeah, Gianmarco showed more sophisticated way with machine learning models and so on. Okay.
Yeah, so as we are seeing, if we go to our block number 1, we have here its hash, and then if we go to the block number 2, we have the transaction and the hash of the previous block. So yeah, basically right now we are also able to fulfill the exercise that I mentioned in the beginning. So yeah, I will pass the microphone again to.
Yeah, the idea is, of course, there are lots of things that you have listened about that are missing here, okay? And yesterday and even today with Gianmarco, but the idea is in a simplified way to see things work, because that was the main idea of this section of the school. For us, it's also a learning process, so it's probably, or it's quite likely that we are making some mistakes, but that's part of the game. Yeah. Yeah, yeah. João will. Yeah, this. No, you should switch on. I think there is a button. Yeah, it's one of the standard algorithms. I don't know exactly what it is, but João knows. But yeah, we ask.
So it's,
Yeah, actually, yesterday Hugo made me the exact same question. So basically, we are trying to use the most standard algorithm, which is called SHA, and then I think the most common is SHA-1, that uses a byte, for example, of 160 bits, but then we are representing here as 265. So
Okay.
the name is SHA-265.
okay, I see.
Sorry, yeah, I think it is that one. Anyway, I can show you here, and yeah, we basically go to the class. Yeah, so yeah, we have here the hash lib, that is basically the package in Python that allows us, and then I was making a small mistake, but yeah, it's quite similar.
Okay. So now you see that the idea is now also for you to come here and also play. Okay. So see things in action, and then probably we looking at our planning, just also discuss a little bit the the steps that are missing here, and how we could then look forward to go until the final authentication file, which then of course can be introduced in the framework, the digital framework of blockchain applications. Yeah, if someone has any question, even for Lan, Mireille, and Gianmarco, because they are. Yeah, Samuel has a question also.
So, thank you for the demonstration, first of all. I have a question. I don't really understand why do you need these hashes? Why do you use them?
So the idea of the hashes is actually to link the information related with this particular candy to make them unique. Okay, so the hash is only a part of the whole process. Okay, and João was showing here. So if we look on the block, so basically each block contains the transaction ID or the transaction hash and the previous block hash. So basically the block is, so we are actually producing the elements of the blocks. Okay, we're not producing the blocks itself. Okay, and then this information goes to this authentication file that Gianmarco mentioned, and then it could be part of the blockchain framework. Okay, so this is just a slide, so we cannot really generalize this, so it's just a step that we need to go until the block, and it's probably where the idea here is to show that, okay, after having our results of the sensor, we link this to an hash, and then of course we go to the authentication file, and then we go to the digital framework of the blockchain. Depending, of course, then the application is, as you saw before, can be really different regarding what you are looking for, the objectives, and the kind of networks and the application that is required.
So you have one hash for each color, or you have an hash for each experiment?
For each experiment, yeah. Okay. So in this case, it's for each candy. Okay.
Okay. Thank you.
And then we link to the previous one to make sure that the chain is functional.
Sorry, what?
So in this case, the idea is to, if we imagine that we go until the full process of the blockchain, so this means that we could not modify the order of the measurement, okay? So that's why. So we measure in this order, and if someone, for example, try to switch the color order, it will not be possible, okay?
Okay, thank you.
Now Mireille, one.
Yeah, and maybe just in addition to why we need the hashes also, before I ask my own question. So blockchain, remember that it's about creating a ledger of non-mutable lines. So the reasons why we use these hashes is to make sure that we cannot ever, it's basically to identify the block. So, or maybe you can help me out to further explain it. But so that's why we need the hashes. And then the blocks are connected by having the hash of the previous block. And my own question was, I forgot my own question now. Yeah, maybe it'll come back to me later. Do you have a question?
Yeah, maybe I was just wondering, do you understand the function of a hash? That that is one of encryption mechanism. Is so even the measurements has changed a bit. The hash would be very totally different. In that way, it's very difficult for someone to reverse engineer what the experiment was. So in that way, you make sure that the sequence, the measurements were exactly the same as it was. So. Yeah, if someone said, well, it's not true, I saw 4 greens, and I try to reverse the data, it will not be possible. So I hope you have remembered.
No, but no. In addition, maybe also to compare it to a traditional centralized system, you would also be able to maybe, if you have the right authority or rights of access to data, you could maybe alter results or etc. So when we talk about blockchain in terms of immutability, you cannot change the data. That's why we're building these blocks with these hashes. Yeah. So no, I think my own question was more about the Python part of creating the hashes, and I guess I'm curious to see how the hashes would end up in the blockchain itself. But we would need some blockchain platform for that, like Ethereum or Hyperledger or...
I can tell you that we are also very curious about that.
Yeah, but I think it's it's very it speaks to the imagination to see how that would work. So it's I think your experiment was very successful.
Yeah, maybe, one thing related to the misclassification of the yellow, yellow
and
color.
the orange, yes.
Because I've seen, I mean, in principle, you're just, there is no actual model, right? It's
No,
just,
no.
let's say, a majority voting on the highest intensity. But, I mean, I guess that maybe, like, if you do many experiments, you will see that maybe there is somehow a way to model the yellow color, even though the yellow color is not the highest intensity, right? Yeah. So probably when yellow and orange are more or less the same intensity, is most probably yellow and not orange. Something like, I mean, this is just...
No, you are right, yes. No, we didn't do anything, but yes, you are right. And probably we could actually use all the inputs of the data, so to select or to classify that. And if you now going a little bit back on the sensor design, you can see that there are some kind of overlap between the bands, which means that the 2 bands that are very close together, they are mostly detecting the same light at the same time. So that's why you find this kind of overlap. But this is more related with the sensor itself. Okay, the idea is here is for us to having several outputs of the sensor, and and the concept is quite familiar to one that we are using in this great project that some of you already have heard about. But we use a very similar concept, which each measuring different optical bands and try to then extract and relate with some chemical information in the same way that you do with the electrochemical sensing. So the idea here is to be in a very, very simple way for you to show how it works, because I think it's the ones that I've been involved in the project. So we discussed a lot, but then the hands-on part is we just we need definitely to play with. So any other questions, comments? No, everyone is very shy. So I think we can probably start if some of you want to come and to see in action play with the sensor for a while. I don't know, Nurian, probably and yeah, we have time. So and probably until the coffee break, and then after the coffee break, João can also then show the data pipeline for iGrape, which does not have anything related with blockchain, but it's good also to see another example of the workflow that Gianmarco just presented, also for you to see is working now. So it's good because you can see also how it works and how it fails also. So you'll see some of the issues. But yeah, I think we can move on with this. So please come and play.
Are you allowed to eat the samples?
If you get the right classification.
Yeah.
So don't test the yellow.
Yeah, don't be shy, please. Just come here and play a little bit with we can see more in detail and how the sensor works and see the sensor also. Yeah, don't be shy. Then the reward is coffee break, okay?
It's the same sensor technology as
Okay, so I think we are all ready after lunch. We will do a small recap of what we have been doing this morning, and we will have also as a guest another colleague from IBM, Gero Dittmann. I'm not sure about Patrick. So maybe we will be able to see here Gero. Hello, Gero. How are you? Nice to see you.
I'm good. How are you?
Good, good. So I will pass you with Hugo now, that they will tell you a little bit about what we have been doing this morning, so that you can also give us some feedback. Okay.
Sounds great. Thank you.
Okay, good afternoon, Gero. Thanks for being here. So basically, the idea for this afternoon session was, since we have here just a brief recap of what we did in the morning about our approach to have like a kind of more generic implementation of a data flow pipeline. We know that is still incomplete, but it's kind of our starting point to then move forward. And I will just show you very briefly. I don't know, so are you able to see our slides or not?
Not right now. Right now I see the room camera.
Okay. Let's see. I believe that you'll just in a few moments we'll be able to see the slides. We'll just really try to be
yes.
Okay. So what we did is very simple. I will just briefly recap also the ones in the morning. So we tried to basically, based on, of course, on our previous interactions, build a pipeline from the physical layer to the blockchain, although it's not a blockchain, but we have some kind of taste of blockchain by the end, and basically do it in a very simple way. So what we did, we just use a spectral sensor, so a sensor that measures different color bands, and a microcontroller then to transmit data through Wi-Fi. This is just for the people who know a little bit more about which kind of data. So we have these 8 bands, and this is an array of different photodetectors with filters. So we can, by the end, have an array of 8 intensities related with the color of the candy that we used. Okay, so it's these M&M's candies that we put just on top of the sensor. So then we send this data to a broker. So it is the message there, and so basically, and then we just build a database with all the outputs of the sensor, and we also generate like the color based on the maximum intensity observed. Very simple. And by the end, we just try to, based on the structure, identify or generating a hash related with each candy, and try to kind of see the elements of at least some of the elements of a potential block in a blockchain. Okay, so João will then explain you a little bit in more detail the implementation with just running the code. So we are not actually running the sensor right now, but we have already the results, and just show you the different aspects of this. Of course, this is still everything local. We are not having cloud database and so on, but the idea is also to transmit to the audience a little bit what we have been implementing and have an example that will be reproducible and simple. And the objective is then, of course, for us, and your feedback will be important on that, to follow up this and also then to make this as like a tool that we can share and can make available for everyone that wants to try.
Can I ask a quick question, to you? I'm afraid of all slides, the one I don't really understand, I'm afraid is the blockchain one.
Okay, so you'll see first probably Joanne will experiment, and then you can make your comments on this. I believe that probably there are things that need to be improved, but I think it's better first to see that part, okay?
Sure, that's fair, thanks. Hi, Joao.
Hello, Gero, how are you?
I'm good, thank you.
It's nice to speak to you again. So, yeah, as Hugo was saying, in the morning we did run the experiment in real time. Fortunately, we were successful. So, in the beginning, and this was our trial, we did first experiments with orange, green, blue, and yellow candies. And the last one, it was misclassified, just because, I mean, we are not doing any type of analysis. We are just registering the highest intensity of the bands, and then we attribute the color to each candy. I'm not really sure which exactly you are seeing, probably the slides. But right now, I am showing to you the output of the code that we run. Everything. Yeah. It would be nice. Otherwise, it can be. Just a moment, please. But so, in the meantime, I can tell you that the timing of the presentation was really nice because it followed the Gianmarco presentation, and at some point I would say that this is more and less of a draft of Citrus 3, where we generate the data, then we send it to a broker, and then it goes to the database. In this case, as Hugo said, it was a local database. And ultimately, we try to do something that we can call it like blockchain, where we generate a hash for each candy, and we link each block to the previous one. So basically, the first thing that you are seeing here is the database that we generated in the morning, and we are displaying it as a table. And then in the next printing, we already can see the database, but with the color classification. And I can tell you that the experiment that failed, it was this one, where the classification was orange, while the true value was yellow. And we can see that the intensity of yellow and orange bands are really close. And as we are not doing any type of data processing, we misclassified this candy, but ultimately this can be a future advance in our demonstration to make it more even more real. Then we prepared the data to put in the blockchain, where basically we define the simple so-called transaction, and we keep the ID and the color of each candy. And then we build the blocks. So firstly, we can see each block. So the initial block has only the first transaction, while the second block has already the transaction plus the previous block hash. And so on until the last experiment. In the next printing, what we did, it was print just the hash of each block. So if we can consider the candy with ID 2, oops, yeah, as the same hash of the block 1. I hope that, no, yeah, I'm not able to highlight both cases, but yeah, this was the simple case that we performed in the morning, and I think this is a wrap-up of what we have now. In the meantime, we also in the morning, we did somehow an exercise where we were able to fulfill each block with the hash and the transaction, and of course, in the block with a number higher than 1, the previous block hash.
Okay, thank you. So, and here's Patrick also. Patrick, I'm afraid you just missed the summary of this morning.
I just caught the last 2 minutes.
Good afternoon, Patrick.
Hi, good afternoon.
All right, so let me summarize what I heard, and then please correct my understanding until we're on the same page. So what I understand is that you have a sensor that can differentiate different colors based on the color intensity. The intensity that it measures, and the idea is to differentiate different types of M&Ms based on that. I think I saw a table of experimental results with that, where you show a few mischaracterizations, but also of course, the correct characterizations, where I assume you checked which M&M you presented and the sensor maybe didn't get the right one. Is that correct already?
Yes, that's correct.
Okay. And then you basically did a series of experiments where every result that the sensor generated was stored in the blockchain. My first question would be, so when do you define, how do you define when you've achieved a result? Because I assume the sensor will continuously produce new readings, but at some point you have to decide, now I take the last so many readings as my result that I now take and store on the blockchain.
Basically, you want to explain? Okay. Basically, each time we run the sensor, we obtain 8 intensities of different colors that are attributed to a candy, and then ultimately the band with higher intensity we classify the color, and that's our experiment number 1. Then we run again and we have experiment number 2. So basically in the morning we started by doing 4 experiments consecutively, and we run the entire process, but then we were just playing a bit, so we run one again, and it was like an iterative process on the final
okay
stage.
So you have a well-defined reading process that I don't know, at some point you push a button and that says go, start reading now. You take 8 measurements, if I understood correctly what you just said.
Exactly.
Yeah, and then these 8 measurements are the package that you then analyze, and the result of which you put onto the blockchain.
Exactly.
Okay. It's interesting because you still showed us that you use a broker, right? A message broker, which people like Gianmarco and Patrick really need, because they produce continuous readings, if I understand their process correctly, but maybe I'm wrong there too. So far, Patrick is neither nodding nor shaking his head. And when you have such a well-defined process like what you just described, you could also just package them all up in one message that you send directly to a server, right? But it doesn't make it wrong what you did. It's just an interesting design choice, I would say. But then my next question would be, okay, so you have somebody receives these 8 readings, so you have a component, presumably, is that on the other side of the broker? So some component receives these 8 readings from the broker, and then runs an analysis to determine which color this most likely was. Is that correct?
After each experiment is stored in the broker, the next step is to send it to a database. I think in the morning Gianmarco said a proper database, that it was Influx database, if I'm not mistaken. Here we are just using MySQL, so it's a local database, and then ultimately we retrieve the data from the database in a simple Python code. And yeah, it's not like then we are classifying the color. We are just adding one more column to the experiment.
Okay. That's very interesting what you said. So you basically have 2 start buttons. One start button starts the series of 8 sensor readings that is then sent via the broker to the MySQL database, and then you would have another start button that says, now look what's in the database, analyze it, and tell me which color that was?
Exactly.
Okay. All right. And then you so the second start button starts the analysis, kind of the authentication process, as we called it in some other diagrams that maybe you've seen, right? You're trying to check whether you can identify it, and hopefully in a secure manner. And then you take that result and you store it on a blockchain. I would contrast that, if you remember what we talked about last time, and maybe Gianmarco showed you a reminder of that today, where the output is an authentication result, right? That is stored in a token that can be used by services, for instance, to give access to something or not. And as an alternative to this process, you decided that you just take the analysis result, and rather than putting it into an authentication token, you just store it on a blockchain. Would that be fair?
I mean, that actually, I think me, Hugo, and Alvaro would like to do that, but as we were not able, we just put the result directly in the blockchain. But yeah, ideally it would be like, as you said, and as Gianmarco explained it in the morning with more detail. Yeah, I would like to learn that as well.
Okay. That is good to hear, because that already answers my next question. My next question would be, what do you gain from just storing it in a blockchain? And I think your answer is, well, that was not really the intention.
I think here the win-win situation is just, we can see somehow at least the hashing code working in a sequence of blocks that more or less are immutable. I think, at least we try to respect the basic concept of blockchain.
Yes, no, very much. So basically what you're doing is you're using the blockchain as an immutable log of what you've seen, right? And that is definitely one common use case of a blockchain. You would still have
that makes...
Sure, pardon.
Sorry, didn't mean to cut you off, Gil, please.
No, go ahead.
Yeah, no, this is great, Joao. And I wanted to take a step back, because I probably missed it. Apologies for that. But the way you translate the sensor reading into human interpretable color, I missed that particular piece of the puzzle. So is that a Python script? Did I catch that correctly, or is it another way? Is there another way that you generate this result that you then store to the blockchain?
I can explain again, but as I'm probably Hugo, it's better to explain like with more detail.
No, this is...
You can speak here if you
I think it's working now. Yeah, Patrick,
Yeah, I can hear
yes.
you.
So we did a very simple approach at this stage. So we recorded the intensities of all bands of the sensor. And what Joan did was just a script to, based on the highest intensity, just select the color, okay? It's just very simple. We didn't do anything really, could be, of course, more complex and probably less prone to mistakes, as also João mentioned, because sometimes the bands of the sensor just overlap and you get very close intensities because you are having the same wavelength basically measured in two bands that are just together or just on the side of each other. Yeah, and you touch in a quite interesting point because we actually during the break we are discussing also in some ways to improving let's say this capability of color detection. And try to do in the future actually that we can then discuss further on something that put some tools that could actually give a more accurate prediction of the real color of the candy. Yeah, but at this stage the idea of João was okay. We have 8 outputs and we have, based on the intensities of these outputs, we select the color of the candy based on the highest intensity. Just that.
Yeah, okay, no, that's very good, and maybe Gabriel together, because the step I'm trying to make is, I think what you'd like to do, right, is what you just explained, would be to create some sort of authentication token, for lack of a better word. And I'm wondering if the tool that you're already using now, right, the simple script, if anything else is needed actually to generate this, so to generate the output format that contains this token, right? So you don't just have the color information, but you also have the information that is related to the use case or the process. Yes, this is good, or no, this is bad, or whatever other classes may be important. So I don't know, Gabriel, you have a feeling for this? Maybe I didn't catch so you mentioned script. So is this a Python script, or what kind of language are you using for this evaluation?
Yes, we used Python. And regarding the libraries, I think for the blockchain itself, we used the hashlib package, which inside has different algorithms to generate the hashes, and we used hash 256.
Then Patrick, if I may, quick question to that one.
Yes.
So are you using a blockchain as well, or is this your own implementation of something like a blockchain?
Yeah, it is the second one. It is something like a blockchain. But at the end, you already touching 2 key points that are the tokens and the authentication tokens, and I would say definitely working on something to classify the colors, because we did not apply any type of algorithm, and we saw in the morning that there is some regression, some classifications algorithms that Gianmarco mentioned, and I have been working personally. I have been working on them too, but on nanomaterials. So yeah, it will for sure be nice to develop something here. And with this type of sensors, although they are really simple, they can generate a huge amount of results quickly. So yeah, for sure in the near future we can develop what we already have. At least we hope so.
Okay. Yeah, this is really interesting. I mean, my understanding so far was that the sensor part of what you've shown is anyway more a toy example than a sensor that you would do research on, because I think you had some very advanced sensors. I mean, the entire INL team you showed us last time around, and this looks like this is more the focus on the pipeline, or is that unfair to your sensor?
Yeah, I agree. I think we can detail a bit more, but I believe that these sensors are commercially available.
Yes. Yeah. So actually, the idea was do something simple that could be easily reproducible and make make it working very quickly. And of course, we could do this exactly with the sensor that we are using, for example, in the iGrade project, which also measures reflectance. But the implementation will be more complex, especially on on the circuitry and the electronics part. Yes, and just complimenting a little bit on the comments and also on João's comments is so we definitely we found that like this as a first step, and we definitely would like to go further on and elaborate a little bit more also on the reference database to have a generating authentication token by the end. And actually, I've been discussing during break to find a way to do that, and probably, also do a very simple classification model just to make sure that we can, properly assign the color to the candy, and try to make this as kind of a tool for us to just very easily explain the concept, how it works, and then for everyone to be on the same page very, very fast. So then in the morning also we had the people after the demo just played also with the sensors to see the different steps. Of course, we know that this is still very limited and there are limitations on the process, but I think it's the first step.
Yeah, no, absolutely. I mean, don't take me wrong. There was no criticism in your approach. Quite the opposite. I think it's makes perfect sense to take a simple sensor that you can control better, so that the sensor is not the problem, nor the pipeline, the early stages of the pipeline, but that you're focusing on what you're focusing on here, namely what to do once you've interpreted the results, right? That makes sense to me. Maybe a comment on the blockchain approach here. So that part, I think you might have invested a lot more work than necessary, although it probably was a good learning because it really, I think you now really understood what this concept of a hash graph does. But it might be even easier than what you did with generating your own hash and so on, to just use an SDK of an existing blockchain to write to an actual blockchain, because that would basically allow you to pass a payload to the blockchain, and that payload would be your classification result, and send it, and that's it, because the rest of the complexity is done by the existing blockchain implementation, right? And that would be basically using the blockchain like a database, just with these special properties of being distributed and immutable because of that, and so on.
I think in this case the main advantage it was that we could develop our own code and learning while we were coding and developing our idea. But yeah, that would be of course a nice approach to try to use something that is already done, and ultimately we can see the decentralization approach working, because in the moment we are just running this on my computer.
Yeah. Hugo?
No, yes, just commenting, João, I think it was an interesting learning process, but I think it's just the first chapter. Yeah, we need to just follow up and go. But it's pretty interesting that the project you also mentioned, of course, is taking advantage of the frameworks that are already developed and that make all the process simpler. Yeah, that's pretty interesting.
Right. I mean, maybe just security from the security philosophy, to make you aware that what you implemented now is not actually immutable, right? Because I assume there's only a single copy of the hash graph, and that is the one you have. Exactly. So you can throw away the hash graph, generate a new one, and no one can prove that you lied.
Yes, exactly. That's right.
So the immutability, the immutability comes from the decentralization, that there are many different copies, so everybody can fetch a copy of the actual authentic graph and show that yours is not the right one. But okay, so maybe that's part of the learning that you already went through now to understand considerations like that better. That's great.
But to be clear, right? So overall, from INL perspective, so beyond this particular work, is that where the area of interest lies? So not in let's say connecting complex sensor signals into this, but we truly focus on the essence of the pipeline and let's say the minimum components that are needed to implement a kind of writing to the blockchain. Is that right?
Yes, Patrick. Yes, that was the objective. Yes, keeping the sensor as like the most agnostic possible, let's say, and have something that could be like easier to understand for everyone. Although, of course, then really depending on the application, and there are several sensors that people is different groups are developing at INL. The output can be simpler or more complex than the one that we showed today. So that will definitely depend a lot on the application and the information associated with that. Of course, there is lots of complexity that we may also think about. For example, if we think something that measures a full spectra, or that with a lot of points, or in this case we have 8 intensities, but if you measure like a NIR or a UV spectra, you are talking about hundreds of variables. But in some cases, probably you also do. You may also already have some calculations, and just by when you need to transmit something out, so we just transmit the calculated value, and you do some kind of edge calculation already in the devices. But that will depend a lot on the application, on the kind of sensor that you are using. So that will depend case to case. In this case, the idea was have something that was really simple, and that could be, really easily understood for everyone, because it kind of the color will be really easy to, and the sensor is very simple, and I think that was the idea. But yes, I agree that definitely the sensor can have different levels of complexity regarding the information that is needed to send, and the degree of calculation in the raw signal that we applied before sending the information to a broker or database. That will depend very a lot.
Mm-hmm. Yeah, because we have these different layers, right? So it's interesting to understand where you would like to go from here, right? There is for sure the digital layer. There's the the analytics piece. There is sort of I think what Gabriel suggested, right? That one pushes more on the blockchain piece. So what kind of formats do you need to write to existing blockchain frameworks? So I think, have you already thought about where you would like to go specifically from here?
I think when we started, it was a couple of weeks ago after the previous workshop, and we were discussing that somehow it was missing something more practical, at least for the people see how it works. So our first idea, it was, let's try to have something. And then when we achieved it, we tried to be a little bit more complex. And then a few days ago, we were discussing, okay, we are respecting at least the basic concept of a blockchain, but of course that we are not doing any type of data analysis, neither respecting the decentralization of the blockchain. So yeah, I would say that those are the 2 next big steps. And regarding the application itself, we started with candy colors. I mean, candies are nice, but we can put more complexity on that, as for example the grapes themselves, because they have different colors at the end, and we do not have just the intensity of the bands, but we have full spectras. So yeah, I mean, there are a lot of options, and yeah, for sure, at least that I think we are going in a good pathway.
Yeah, this is a great example and starting point. So I don't know what you think here, but I absolutely agree on these two things. Like have somehow a use case or elements of a use case that reflects kind of the trusted food supply theme of this project, and let's say the decentralization aspect, as you framed it well as well. I think so. I personally think those would be 2 very good next steps.
Yeah, I have 2 more aspects to look at. One is, you already mentioned it, right? How to get to these authentication tokens, and we can talk about that a little. How to think about that. The other thing that just came to my mind is, if I understand correctly, the output of your process right now, the analysis result, is a single color, right? It says yellow, and no,
yes, that's right.
Yeah, okay, right. I think, Patrick, your pipeline gives probabilities or percentages of likeness, right? Of multiple colors, if you will.
Not at this stage. No, at this stage is a pure measure of the maximum intensity. We're not doing any kind of approach to try to infer the likelihood of some color or the probability of the some color more than the other. This is something that we will discuss during break. That could be really nice to implement.
Yeah, it could be interesting.
And actually, based on what also Gianmarco showed this morning, where we on this the authentication token that also includes the class defined plus some information about the likelihood of other possibilities that are also under study in the same sensing scheme. Yeah, that definitely. So, yeah, also try to kind of also merge also the comment from Patrick. Definitely, I think this is like one of the parts that I think the authentication token will be like a major objective more on the technical point of view to implement these different parts on the pipeline that we think it could be interesting to evolve this and then definitely I think it's probably more challenging, but also find some something more close to a use case where we could see this in action, probably with for us also probably with more than one sensor. That could be also interesting, yeah, definitely.
Yeah, so my comment was actually about Patrick's pipeline, right? That and Gianmarco's pipeline, that they have these percentages, but apparently you talked about everything that I can ask about already today. That's great. So
yeah, at least we have. Go ahead.
Point was, Patrick.
No, you go ahead.
Okay, my point was actually just beyond that. So I think what your process tries to do, and also the other IBM process, is to take an unknown substance and then come up with a best guess of what this substance might be without prior knowledge, right? Whereas many crypto anchors we see in the field actually do take into consideration what the scanner hopes to find. And this is interesting for instance, you could have a situation where you have a result where two colors are almost equally likely, but one is just a little bit more likely. And then the process takes out that and maybe says if you were expecting yellow, but the slightly more likely one was orange, that you have a counterfeit, right? If you think of in terms of authenticity. Whereas if you were to consider that I'm hoping to find a yellow one and your sensor says, well, it could also be an orange one, but yellow is also not much less likely. Then the process could say, yeah, with reasonable likelihood, if you're expecting a yellow one, this is probably a yellow one. Am I making sense here philosophically?
Yes, yeah, I understand your point, but yeah, definitely this goes on the side of the application and the degree of trying to think how we can, for example, translate that when developing. So basically, the sensing capability of course, distinguish between similar colors, but between intensities. That's why probably it could be also interesting when we consider some also classification or kind of fingerprint, not only be focused on the highest component or the higher components of the signal, but also probably in how they related with the other ones that are minoritary on that. So the minor components, that could be also interesting. For example, to see that, so we may have on the surface, for example, kind of orange, but then when it interacts with the layer, that because the light will interact with more than one layer for sure that is there, you also find that the other bands with very low intensities, and probably another one that is for our visual on the high, it will be very similar, but then you'll see that the other bands, the minor bands, could be modified. That could be also something can probably emerge between the log of the signals plus the classification model that could also assign the sample or the candy to a particular color. Yeah, I'm just try to see how we could tackle that in a real case scenario.
I only disagree with one statement of yours, and that was the first one, that this would be part of the application already, right? I would argue this is maybe an additional interpretation stage of your classifier, or maybe it's just a modification, because right now you end up with different readings for the different bands, right? And then you have one stage that then decides what to make of this result. And in your case, your decision stage just picks the one with the strongest intensity, and that's it. And that stage could instead consider an input from the outside, another one, what is the color I'm expecting? And then if that is amongst the highest, still say, yeah, if that's what you're expecting, it's probably authentic. Or could say, well, if that intensity is very low compared to other intensities, it's not likely that that we can confirm your expected reading. And then that would be the output of your authentication or classification stage. Does that make sense?
Okay. So it's like authentication criteria, right, Gail, what you're saying. And this could be threshold based, but it could also be a classifier that's working with similarities on a training set of samples or something. So the criteria itself may be informed by the application, Hugo. But I guess what Gail is saying is that there can be an authentication criteria as part of the script, whatever that may be, right?
Yeah, and I understand your point. So yes, I understand that we always could. Of course, I understand the point that of working on the data that we have and generating more layers of information that can help us then to on the application side to be the easier way to interpret the final result, which in this case will be like the color assignment. But of course, doing that with different degrees, so we can of course do it as we are doing right now, just getting the highest value of the readout. But then we'll see that there are failures and try to find some ways based on this information to increase our reliability on the process, our accuracy classification. And also I understand the point that this could be important regardless the final application that we are looking for. Yeah.
Mm-hmm. I think from both of you are saying we have to take into consideration not only the amount and the diversity of data that we can generate, but additionally, as you were saying, as an external or an extra factor of validation before taking the final decision, it would be what the so-called nowadays of metadata. And I think, currently we do not have any metadata. For example, in the morning, Gianmarco said the example of decision step, you consider the calibration curve. And in this situation, we do not have any so far, but I think it can be an interesting option in the future.
Okay.
Yes, and just commenting also, of course, there is also some potential adjustments in the sensor that we can do to increase the level of the information, because we can for example change the LED intensity and things like that. We are not using that at all at this stage, but yes, there are some other ways at the sensor level that could also help in this then the feature that we want for the classification in this case of the candidate, definitely.
Sounds good. All right, the last thing that I would want to look at is to maybe give you at least a rough idea what I have in mind with this authentication token and what it takes to get from where you are right now to go there. Would this be the right time to talk about that? Or Patrick, would you have other points in mind?
I think that's a very good suggestion, Gero, and just wanted to share with the INL team that I have a bunch of ideas coming up now for things that we can explore during the upcoming secondments. So a lot of food for thought there, which I'm going to be very happy to follow up on with all of you. So, but I think your suggestion, Gero, is perfectly right for this moment.
Sounds good. Hugo, Joao, you okay with that too?
Yes, we can discuss about it.
All right, and maybe just for a clarification, so I understand it correctly that what you're trying to do now is to build a generic pipeline that other teams in INL could also use for their sensors to make use of different types of sensors for authentication decisions. Is that a fair description?
Yeah, if that would be possible, I think it would be the ideal scenario. Yes.
Great, great. So I'm very happy that you picked up this idea, which I think came up in our last workshop there. Right, this is great. All right, then maybe just a brief discussion of this authentication token. So I think what an authentication token is supposed to do is kind of wrap the information that you've already generated. The authentication information that you're generating is the color that you identified. And the idea of wrapping that in a token is to, first of all, make it readable because it follows a standard format, a JSON format typically. So to make it readable by consumers who are interested in the result of your authentication process. And then also to wrap it in a signature so that imagine you're operating an authentication center, right? You're operating your sensor to certify for people that drop by that their candies are the right color. And then there should be third parties that would be interested in your classification, and they want to be sure that the information that this M&M is really yellow comes from INL. INL vouchers for the correctness of this yellow candy, right? So for that, this data structure is wrapped with a digital signature signed by you with a secret key that only INL has access to. And then the receiver of the token can verify with a public key that this token has really been signed by INL and nobody else. And then they can rely on the information provided they trust INL with authentication processes like that. And so that's what these tokens are. They are a data structure with some basic information maybe and some information fields that you can determine yourself. And then it just provides a standard method of signing this information in a verifiable way. And the content of that, of those tokens, and I'm basically have these Passeto tokens in mind that are a more easy to use and therefore also more secure version of the JSON web tokens, a widely used standard for authentication. So with these Passeto tokens, you have a few fields that are defined by the standard so that any interpretation library would know how to interpret indeed. And those are fields for the issuer of the token, that would be INL. The subject about the token, about which the token makes a statement, that would be an M&M in this case. And for instance, also the issue time of the token. When was the analysis performed? And so at what time did INL issue this token with this authentication information? But on top of that, you can add additional information, like for instance, the geographic location, where you performed this. So that, yeah, basically GPS coordinates, right? And most importantly, your actual classification result, right? So in this case, that would be color. Maybe you would have a color field that says yellow, and maybe you would have an authenticity field that would say, yes, I'm reasonably sure that this is authentic. So basically, you've worked with databases, right? You have your MySQL database. You've defined a schema for that. So you defined what columns you have in there. In a similar way, you would define these fields in this JSON data structure that you want to convey as a result of your authentication process to the recipient of that authentication process. You would sign that, and that's it. The way to do that is simpler than I think this sounds, because there are libraries in many different standard languages that you can just use that will basically ask you what fields do you want to have in your token, what content do you want to put into those fields, and then probably also ask you for your private key, and then the library will package that, sign it, and pass you back the finished token that you can just send there wherever you want, right? And you will find those libraries, an overview of such libraries on a website called passeto.io. And you will find there that there are libraries for, I'm looking at it right now, C, for Go, for Java, JavaScript, Python, of course, PHP, .NET, Ruby, Rust, Swift, right? I mean, basically all the most widely used languages these days, there are libraries available, so you don't have to implement that yourself. All right, so this is basically how you get from the information you already have. You just put that into that JSON, have it signed with that standard library, and then you have a data object that you can send somewhere else, whoever should be the recipient of that information. Quick question, does that make sense? Was that too much already? Am I boring you?
Yeah, I think to me is making sense, and it is in the sequence of Gianmarco in the morning explained. Probably right now with a little bit more detail, but yeah, the thing of the JSON JWT files, yeah, we spoke a little bit about that in the morning, and yeah, right now it is a little bit more clear.
Okay, great. Then maybe let me say just a few words about the recipient. So the recipient could, for instance, be a web server that holds important information that it will only show to someone who can prove that they have a yellow M&M. So that web server would be the recipient of your token. The web server would also use a similar library, or basically the same library that I mentioned, to analyze the token that they received from you. So they would first of all verify the signature. For that, they need the public INL key. They would use that to verify that the signature of that Passeto token really protects the current content of it, and the content hasn't been modified since you signed it. If that is established, then it will unpack the content of the JSON structure, and in it, it will find one field that says yellow M&M token, another field that says it's authentic, and maybe a third field that says this token comes from INL, although you kind of know that already since that's how you verified the signature. And then the web server will be convinced that INL has confirmed that whoever sent that token has a yellow M&M, will give access to that very important information on that web server. That's, I know, a really stupid example of an application. I kind of depend on you to come up with better use cases, but that's how this authenticity can be used in applications. And by the way, another example would be a blockchain front end, right? Where you have a server that interfaces to a blockchain that interprets your token and says, okay, so now I know that INL has confirmed the authenticity of this, or the yellowness of this M&M. My application use case is I want to log all the authentication analysis that INL has performed. So I will take that information and store it on my blockchain. So it's kind of introducing an indirection in what you've already done in your use case so far. So far, you just took your authentication result and sent it to the blockchain or to your representation of a blockchain directly. Instead, you can transform it into a JSON token, send it somewhere else where somebody has a blockchain service, and that blockchain service would unpack that again and then do exactly what you did, store it on a blockchain. And the advantage over what you did so far is that that token can be used by all sorts of services, right? Not just by a blockchain logging service, but by a web server, by a building access system, by, I don't know, a video server that shows you a beautiful Disney video whenever you have an M&M, things like that. And I think that completes basically the overview, hoping to give you some context how to think about these tokens, how to generate them, how to decode them, and how to think about them, what problem they solve.
It's okay. Okay. Yeah, Gero. Thanks a lot for your inputs. Yeah, I think we have a lot of also food for thought on our side, and definitely some ways to follow up this and get there. Improve this and definitely go for the authentication tokens and be there as like the block of the information that we need then to be able in different platforms and different applications. That will be really interesting. Yes, thanks a lot for the inputs.
Yeah, thank you. Thank you so much.
I don't know if anyone wants to ask any questions, make any comments. No, Lorenzo? Okay. Yeah, no. No, everyone is very shy. Don't be scared with the blockchain, okay?
The problem is that we were too clear.
No, I hope that just trying to also make a connection, because you saw also in the morning, and also to see, I think it's also interesting for you in the audience to see a little bit the starting point and also what Gero suggested as a follow-up. I know that for the ones that are not very used to some of these concepts, could be sometime at some point more tricky to follow probably some of the details, but I think the main idea, at least, is exactly the just follow up of what Gianmarco present this morning. So he's just trying actually to get to the authentication token, which will be like I don't know if it's the right wording, but Gero is there to correct me if I'm saying something that is technically wrong, but should be like our, the step or the block of information that just gives us so the signature of all the information that we generate that then could be used for the blockchain or other platforms that could be also useful for this. Comments, questions? No? Lorenzo, you want to? Nuria, something to? I think we are mostly done. Yeah. Thank you so much, Gero and Patrick, for your time and for being with us today again. And I will just give the word to Nuria.
Yes, thank you, Gero and Patrick. So I was just going to say a few words for tomorrow planning as we are done for today. So tomorrow we start again at 9:30 and we will have invited speakers here presently from the Sapienza Università di Roma. What happened? He was waving. Then we will have a presentation also from Marta Prado, one of our colleagues. And let me just see the program because I'm forgetting now. And after the lunch break, we will have a speaker from Wageningen University on machine learning and digital twins. And then finally the social activity to the winery. So if there were any people that still wanted to join, it's still possible. And that will be the end of the presential part. Then on Thursday, we will have 2 speakers online. So if you want to join online, that's also possible because we will not be here presently. Okay, so thank you very much for your work and the explanations today, Joao, Hugo, Alvaro, and a lot of effort, yeah. Okay, so thank you very much. And thank you everyone for participating. Bye-bye.